we are back to another round of Turing Mock Interview series. I am Jose, and I'm tech lead at Turing, and I'm Montreal, Canada, and at Turing, I work, help them with the vetting process. I have more than 17 years of experience, and my expertise lies in JavaScript. Today, I will be interviewing Anuj for the role of an experienced MongoDB developer. Okay, let me know in the comment section below what you think about this interview, and let's get started. So, hello, Anuj. First of all, how are you doing today?
I'm doing good. Thank you, Ross. How are you?
I'm doing great. So thank you for asking. So my first question for you is, I would like to ask you to introduce yourself and tell me a little bit about your professional experience, okay, your background, and then I will take from there.
Sure. My name is Anuj and I have 8 years of experience in technical and management side. Mostly I work with Node.js, Java, Express.js, different frameworks of Node.js. And on the framework side, I work with the Nest.js, Express, and Restify, Strong Loop. And I have worked with microservices and REST-based microservices. And database side, I have worked with MongoDB, Postgres, MySQL. In DevOps, I have worked with GCP and Docker. Yeah, that's all.
Oh, nice. GCP and Docker. Okay. Do you have an experience with Kubernetes as well?
Yeah, I have experience with Kubernetes as well.
Okay, that's great. That's great. All right. So your background look amazing. Okay, I'll check your resume and really look amazing. And my next question for you is, let's see. I'd like to hear from you. Okay, what kind of project have you been working on with MongoDB?
I have used MongoDB in B2B and B2C projects in different domains like AdTech, HRTech, IoT, banking domains for different applications like content management, payments, analytics, personalizations of web and mobile applications.
Cool. All right. And okay, so let's talk about MongoDB then. Okay. And this question is, you get this question in all interview. Okay. What are database in MongoDB?
So actually, first of all, like what is database? A database management system is a software to store, organize, manage, and retrieve data. MongoDB is like a document-oriented database. It features indexes and expressive query languages, atomic writes on per document basis, and fully consistent reads. Operationally, MongoDB offers a master and slave configuration application with automated failover and built-in horizontal scaling via automated range-based partitioning.
Okay, great. And you mentioned that you have experience with SQL database as well, right? So this is not a SQL database, but I would like to ask you this question. What are the difference between queries, okay, using MongoDB and SQL database?
So MySQL is using the SQL, like the name suggests it. So in MySQL or RDBMS, we are using the SQL queries. And in MongoDB, we are using the structure query, like, object-based queries, like how we are using it in codes based on objects. So you can directly store your JSON into the DB, and you can fetch and you can perform different operations on the data directly based on the object. So MongoDB is like as I mentioned, it's a document-based or like document-oriented database, and MySQL and other databases are like for RDBMS. So they are working on MySQL SQL queries.
Correct. And can we create functions in MongoDB? Like we have functions to find, for example. Can I create my own find function?
For find function is like, in that you have to pass the query parameters. Like find query is doing is, so the first query parameter is to provide the query where you have to define what you have to find, and the second query parameter it is taking is projection. So you can which table or document fields you want to be part of the result that you want to be part of the results. So like that. So you can specify anything, and you can, after that find query, you have option to sort also. So yeah, we can provide different parameters and we can customize our query like that.
Great, great. And I have a follow-up question for this. What's the difference between find and find one?
So find and find function, these two functions are for querying the MongoDB database. Find is basically like, searching for all the documents which is matching to a particular query. We can provide two parameters, like one is query, like where you have to send what you want to search. Like you can search for the Anuj name as Anuj, which is present in the Delhi. So it will give you all the records which is matching name as Anuj in Delhi. And find one is like, if you search for all the records, same query we can pass in find one also. And in that there you will get only first record in the query. So this is a different find will give you all the records which is matching to the query, and find one will give you only the one record, first record, which is matching to the query.
Okay, great. All right, Anuj. Then I have a challenging question for you. Okay, let's suppose we are searching for name, and in a point of time, this query gets starting getting slow. So what could we do?
Thank you for asking this question. Actually, like I mentioned in the previous question, so we can pass query in the, when we are using find operation, we can pass query. And if you are using without any index, so what it will do, it will check for all the documents in the database into the particular collection, and it will match with each and every document. So it will be slow. Like consider you have millions of documents, and it will be checking with all of them. So what you can do, you can use indexing. Indexing, basically what it will do is like, it will store metadata about your collection. And for those particular fields, like you will be using name or city maybe heavily. So you can create index on those two fields. And after that, you can, whenever you will be using the search operation, so MongoDB will first search in the index. And when it will find, it will, just return or like the cursor for those two documents, which is present, those 2 or 3 documents, like, which is finding by the query. So the cursor will go to the particular document and it will return. So there is MongoDB is providing one more function, explain function. So you can check your query using explain function, and it will give you a status, in the RAM, how much RAM it will going to consume, like, and how many documents it will be taking. So consider there are 4 Anuj in the collection. And if your querying is taking 8 or 9, scanning 9 documents or 10 documents. So your query is, you're doing something wrong there, or maybe your index is wrong. So your optimized query is such like, if you have to search for n documents, it should scan for n documents only. So that is the best index, and that's a way you can use your queries.
Cool, really cool. So we are talking about indexing, about documents. Okay, what are documents in MongoDB?
So documents is basically an object where, like, collection of fields, where you can see a collection of fields in an object where you can share the store database. Like in MySQL, you have rows and columns, right?
Right.
So in the collection, okay, let me explain you like how MongoDB and MySQL, like I will compare. So in MongoDB, like we have the tables, and in MySQL we have the tables, and here we are calling them as a collections. And in that we have different documents, or we can say particular objects. And in MySQL, it is referred to as rows and columns. Okay. So consider we have a different rows, like one row represent the data, right? And the column represent the name of the column. Basically name, city, country, like that, right? In MySQL. So here we have the object, JSON object. A JSON object will be called as a document here. And in JSON object, you can have nested JSON objects also. MongoDB can store multiple types of data types. And this is the beauty of the MongoDB. You can use directly, you're working with data like JSON, you have to store your class object directly. You can store directly into the MongoDB without worrying about the schemas and everything.
Cool. You talk about documents, collections, okay, find one. So what's happened if a document starts getting bigger? So how do we scale up a document using MongoDB?
Okay. So MongoDB is we should store all the related data together. So there are limits on documents also, like we can't have a large GB, 1 GB of data documents. But what we can do, we can use references, like if you want to use. And for scaling up, like we do have horizontal scaling and vertical scaling. Vertical scaling is just like increasing the RAM, like hardware and all. So we do have horizontal scaling, like we consider you have a big amount of data, like we are working on an application which is storing the geographical data of all the world, like you have a application working in America, also in Germany, in India. So what you can do, instead of storing all the data in one go in one database, You can use sharding to horizontal scaling for horizontal scaling. And in that, what we can do, we can have a different shard. Like, we have one shard key, and using the shard key, you can divide your databases. Like, we can have multiple shards, and you can store particular city data and in one shard, so that you can query faster instead of searching in the whole, storing data all the documents in one database and then searching over there. You can shard, you can use horizontal scaling, and you can search for in a particular small set of data. So that will be easy and it will be faster also.
Okay, great. All right. So, and how could we perform transactions in MongoDB?
Okay. So transaction is like, first of all, it should be like whether it is committing or a rollback. When you are doing something, consider you are writing a code, you are committing something in the database, right? You are writing or you are reading. So basically, maybe at a time something happened and your database, like you are going into the ATM and you are doing some transaction and something happened between that. So it's not like, if your money is deducted and it will get rolled over. So it will not actually getting deducted from your account. So transaction is basically, a logical unit of processing in a database that includes one or more database operations, which can be read or write operation, right? So transaction provide a useful feature in MongoDB to ensure consistency like that. And it will be, we can use two API for that. One is core API and one is callback API. The core API, it is like a similar syntax like a relation database, start transition and commit transitions. So I told you, like, start and commit transition. So basically, whenever we are using this transition, we will define the start of it. Yeah, like from here we are starting the transition, and the end of it. Like here we are doing, like at a one point it will be committing. So if something happened between them, that part, so we have to roll back. And if everything is good, then we will be committing. If it is all back, then everything will, from this, like we will back to the starting point only, and there will be no change in the database. And if we are doing the commit successfully, then only you like consider you have to two write operation or multiple write operations. So basically at that time we are using transitions to maintain the consistency in the database.
Great. And which one do you recommend to use? Core API or the callback API?
So we have to use both, like.
Sorry.
Okay, so let me tell you about the callback API also.
Okay.
So this is
again, because I think we cut out. Okay. Okay. And which one do you recommend to use? Core API. Sorry. Again. And which one do you recommend to use? Core API all the time, or callback API, or a mix of them?
We can use a mix of them, like, according to your use. I actually, like, Joe, we can skip this question.
Keep.
Like, this is not important.
Okay, let's move to another one. Replica. Okay. Sure. All right. So, can you hear me?
Yeah.
All right. Great. So, what is a replica? Sorry. Again, what's a replica set in MongoDB?
Okay. So we discussed about indexing and how we can scale horizontally. The thing is, we are talking about only one copy of MongoDB, right? One copy of your database. What happens if it is going, because of physical damage or something like that? Your one of the data center is going down, and so you won't be able to access your database. So to remove, to get rid of these type of issues, we are doing the replicas. So we are storing data in replica set. Like consider we have different continents, and so you can store it. It will be easy to avail the data also. Consider you have a data center only in Germany. So you will be fetching data like everywhere from every time you will be fetching the data from Germany only. So we can have a different replica set of data, and we can, so that it's like a same copy of data, identical to each and everyone. And we basically, MongoDB provided this use this application to keep your application running and your data is safe. Even if something happens to your one or more servers, such replicas can be created by replica set by MongoDB. A replica set is like a group of servers, which is one is primary and the server taking writes, and multiple secondary servers that keeps copy of your primary data. If primary data crashes, the secondary data can elect new primary from among themselves. So you will be having the high availability using this. So there will be no downtime if you're using replica sets.
Okay, great. And what is aggregation framework? What's the aggregation framework in MongoDB?
Okay. So basically, like first we discuss about queries. So queries is just like, sending, finding data on the basis of some of the conditions. But if you want to perform certain operations on that data you have fetched, right? So aggregation framework is a set of analytics tools within MongoDB that allow you to do analytics on documents in one or more collections. It is used to consider like we have to use, like, we don't have join here, right? So but MongoDB provides aggregation frameworks, so you can use aggregation frameworks to fetch data from one or more collections, and you can you sort your database. So like consider you are getting first some of the records using first of the query, then you can use projection on that, you can use sort operation on that. So it's like basically we are using different pipelines here. And pipeline, basically when I'm writing pipeline, it's like when you are doing some of first operation on a particular data which you fetch from the database, so it will be like input to the another pipeline, and you will perform that operation, and the output of that pipeline, next pipeline, will be the input to the next another pipeline. So you can perform series, you can add series of pipelines, and you can modify your data like that. So you can do sorting, you can do projection, and you can fetch data from multiple collections. So you can do everything here.
Cool, nice. And what's a storage engine in MongoDB?
The storage engine is a component of the database that is responsible for managing the data is stored, like how data is stored both in memory and disk. MongoDB support multiple sports engines and like in-memory engines and by-tiger storage engines, which is by default. And as different engines perform better for specific workloads, choosing the appropriate storage engine for your use case can significantly impact the performance of your application.
Cool. And so next question, move on, okay? All right, and how to condense large volumes of data in MongoDB?
Okay, so we can use MapReduce for that. The command line for is like, map and like, you can in camel case, it is like map and R is capital. So a MapReduce is a command. You can use MapReduce operation. MapReduce operation is generally used for processing the large data sets in MongoDB. And that is for aggregated result, you can use it.
Great. So now I'd like to call upon our developer fellow here. So if you have any question that we didn't answer today, drop a message in the comment section below. If you are enjoying this video, don't forget to give us a big fat thumbs up. Subscribe to our channel. And if you are looking for jobs, go to turing.com/jobs. And then you can search for a job that is suitable for your tech stack. Apply for the job, and I'll be a pleasure to interview you in one interview. Okay. All right. Let's go back to you, Anuj, and let's suppose you are performing a query in MongoDB. Okay, and then we want to get the first 10 records in a database. How could we do that?
Okay. So you can use find query first, like, and you can optimize it. Like I will tell you how. So you can use db.collection_name.find query. And in the first argument, you can pass conditions per query, which you want to apply on that. If you want to any, otherwise you can keep it as a blank object. And then you can use second parameter as order by, which will store it, which will sort it in descending order. And you can use natural sort as -1, as you want to see the last 10 documents. And you can pass limit as 10 in the query dot limit. After the function, after the find function, dot limit you can use, and you can define any numbers, like you want 10 last 10 documents, so you can use 10 there.
All right, and let's suppose I would like to get the next 10 records. How can we do that?
So we can use skip here, like before limit, you can use skip, and you can use your pagination, like you can provide 10, and it will skip first 10 records, and then you can start after that. If you want next 10, so you can again use the limit for dot limit after the skip function, and you can pass any number. Like if currently it is 10, so you can pass 10.
Great, that's it. Let's see how to use text search in MongoDB.
Okay, so if you want to search any text in the MongoDB collection, so what you can do, so you can first create an index on that collection. You can use MongoDB.collection name and then create index function. Inside that, you can provide the field, like, and pass the value as text. so like which you want to search, right? And whenever you are querying your database now, what you can do again, you can use find query, and inside that you can use $text operation, and in that you can use nested object, and in that you can pass $search, and in that the value of the $search key will be the text you want to search, and using like this you can search anything in your like for that particular field.
Great, that was great. And this will be my last question for you, I promise. Okay, we talk about replicas, we talk about how to scale up a MongoDB, and my last question for you is, what's the command syntax, okay, that tell you whether you are on the match server or not?
Okay, so we do have one function in MongoDB, which is db.isMaster, which will tell you whether you are master or not. So MongoDB allows only one master slave. So with that function, you can easily find out.
Okay, that was great. And that was actually my last question for you. So, okay, I would like to thank you for this conversation. That was really nice to speak to you. One more question before we finish, okay? So if the developer would like to learn more about MongoDB, okay, where should they start? What do you recommend then? The documentations, where should they get started?
Okay, so MongoDB is providing very good documentation. You can go to mongodb.com/docs/manual, and then you can see. So they are providing for different documentation for different versions, even for the upcoming versions. You can find everything there. So it is very helpful. And also there is one MongoDB University. You can go there and you can learn from the MongoDB universities. They are providing free of courses. So you can do that and you can get your certifications done from there.
Great. Thank you very much for sharing this such valuable information. You are such a great developers. Okay. I would like to thank you everybody else for being here to the end. Okay. And I hope you enjoyed the video as much as I did. We'll be back very soon with many other episodes. We'll cover different tech stack and language. If you are looking for some specific mock interview, please drop a message here in the comment section below. Let me know what more interviews would like to see here. And don't forget to give us the big fat thumbs up for this video. Subscribe to our channel if you are not subscribed already. Okay, you can follow Turing on LinkedIn, Instagram, Facebook, Clubhouse, Twitter, YouTube. Okay, until then, I hope to see you again. Okay, take care, stay safe, and learn more.